Hello, Pojima. Can you hear me? Yeah.
Yeah, hello. Yeah, now I can hear you. Yeah. Sorry,
Yes.
I have to start Zoom again.
Okay. Can you hear me now?
Yeah.
Okay. Let's start our discussion now. Okay, dear.
Mm-hmm.
Wait. Creating topology. Give me 2 minutes only. So we are trying to focus on how to configure advanced routing in FortiGate firewall. Wait. So we have same topology. We have
Mm-hmm.
same topology. Inside router and outside router. Outside router. Port number 1. Port number 2. This one is LAN 200.200.0/24. This one is WAN 10.1.23.0/24. Now we can create loopback interfaces for some root verification. So
Mm-hmm.
2.2.2 on R2 and on R1 1.1.1/32. So let's start our basic configuration first. After that, we can go for routing implementation. So any question from previous session, Bozuma?
No, so far so good.
Okay. Okay, let's configure our R1 router. So fast Ethernet
Mm-hmm.
0/0 200.10 mask, no shutdown. We can create loopback interface 1.1.1 mask, show IP interface brief. Let's go to outside router 0/0 interface 10.1.23.10 mask, no shutdown. We can create loopback interface here 2.2.2/30. Now let's move on FortiGate firewall device. Right click and console. So we are trying to implement today a RIP protocol, routing information protocol, OSPF, and BGP into this topology. Have you set up the lab on your side, Bozuma?
Yeah, I managed to install it yesterday on another PC, another computer,
If you need any
laptop.
help, for lab setup, so please tell me. Okay,
Okay,
I
now
can,
it
I
works,
can,
but it's okay.
I can.
Thanks.
Yes, I can help you. No problem.
Thanks. It works fine
So
from another
you can do
PC.
practice. Okay, please tell me today because then now next session we have on Monday. Okay, so today I
Mm-hmm.
can help you to set up the lab so you can do some practice.
Okay.
Okay, username admin, password I'm using 123, config, system interface, edit, port number 1, set mode static, set IP 192.168.255.195/24, HTTPS, ping, and SSH. So now let's try to access this firewall device. And we can configure IP address as per our, I think IP address is 195. Okay. Unauthorized server could not Identified. Okay, no problem. Let's change IP address. IP address 190. Actually, 195 I'm using for FortiManager most of the time. That's why.
Mm.
Let's try to access 190. So 192, 168, 255, 190. This is our firewall device. And now username admin password 123. As per design, I'm trying to configure IP address on port number 2 and on port number 3. Let's try to configure. Network interface. Port number 2. Port number 2 is LAN interface 200.200.200.1/24 ping service. Click on OK. Let's configure port number 3. Alias, I'm giving WAN. Alias, I'm giving WAN and IP address as per our design. 23.1 ping service. Click on OK. Now let's try to configure advanced routing options. So these are the options. Bozuma, these
Mm-hmm.
are the options we have, we can discuss. So let's just start our discussion with RIP. So what is RIP? Routing Information Protocol. It will always work with hop count. RIP can't understand bandwidth, right?
Correct. Yeah.
So let's go to router. So I'm trying to configure RIP protocol here. It's a very simple task. You can go to router, RIP command in Cisco device, version 2, network 200.200.0. And yes, we have one loopback, 1.1.1, no auto summary. Let's go to R2 router. So router, RIP, version 2, network 10.1.23.0, 2.2.2, no auto summary. Now let's go to FortiGate Firewall. So you can click on RIP protocol. And I'm using version 2. Why? Because if you remember, version 2 is a classless protocol. It sends update via multicast, and version 2 support authentication method, right?
Mm-hmm.
That's why I'm using RIP version 2. Now you can advertise your network. So as per your design, you have 200.200.0 network, and you have 10.1.23.0/24. Just click on apply. Just click on apply.
Mm-hmm.
Click on apply and you can verify your routing table information. Get router info routing table on. So you can verify your routing table information. Okay. Wait, it's
Yeah.
taking time, but you can see you are receiving some root information. You are receiving some root information with R flag. R is what? RIP, routing
Mm-hmm.
information protocol, RIP protocol. So you can see to reach 1.1.1, you can go via this side, 200.10. To reach 2.2.2, you can go via this side. This is administrative distance, and this is hop count. Simple configuration. Clear now, this RIP configuration.
Yes, it's clear. Yeah.
So you can click on apply, it's done. Configuration is done. But in case if you are looking for some advanced RIP configuration in FortiGate firewall scenario, yes, you can implement. Okay, you can go to interface, just click on create new. So RIP other features you can configure in FortiGate firewall if there is a requirement. Okay,
Mm-hmm. Yeah.
so passive interface concept is available here. You can select any interface. You can use any interface as a passive interface, just enable. You can
Mm-hmm.
go with authentication option. So if you remember routing protocol authentication concept, So we have two type of authentication, right? We
Mm-hmm.
have simple password authentication, authentication, and MD5 authentication. If you talk about protocols, RIP, OSPF, they support simple password authentication. They also support MD5 authentication. But if you talk about EIGRP protocol and BGP protocol, they support only MD5 authentication, right?
Mm-hmm.
So this is RIP protocol. So you can enable this, you can enable, and you can see both options are available. Simple password, clear text password, and MD5 authentication. I'm not configuring, I'm giving you idea. You can
Yeah.
configure here. Okay, you can configure here. Now let's go to advanced option. So default hop count is 1. If you want to change for any scenario, you can change. You can inject any default route. You can inject any default route in RIP. You can also change timers, update timer, timeout, garbage. You can
Mm-hmm.
also use redistribution method. What is redistribution? We can exchange different routing protocol information with each other, right?
Yes.
For example, we have a scenario in between R1 and R2. In between R1 and R2, I'm using RIP protocol. And in between R2 and R3, I'm using what? OSPF protocol, for example. OSPF protocol. So both protocol behavior is different. RIP cannot understand bandwidth. RIP works with hop count. Least hop count, best route. But
Mm-hmm.
OSPF work with bandwidth, cost. So if you want to exchange different routing protocol information with each other, you can configure redistribution. You can configure redistribution option. Just enable. Just enable. For example, I want to redistribute RIP protocol, just enable, or BGP or OSPF, just enable, click on apply. Clear this RIP configuration?
Yes, it's clear. Yeah.
Okay, now wait. Now we can go for OSPF implementation. So I'm trying to remove this RIP. So if you remember in OSPF, we have area concept. We have area concept and we need to create area 0 first, right? Area 0
Mm-hmm.
is called backbone area, or you can say transit area.
Yes.
So what I'm doing, I'm trying to advertise all devices, routers and firewall, all devices in OSPF area, in OSPF area, in OSPF area 0, in OSPF area 0. So let's go to advertise routers first in OSPF, router, OSPF, process ID, network, 200.200.0, wildcard mask, area 0. Network 1.1.1, wildcard mask, area 0. Let's go to R2 router, R2 router, ARGRP 10, network 10.1.23.0, network 2.2.2. Sorry, let's say ARGRP. Wait. Router OSPF process ID 10.1.23.0, wildcard mask, area 0. Yes, we have one loop back 2.2.2, wildcard mask, area 0. Let's go to firewall, and we are trying to implement OSPF protocol. So now first you can define what? Router ID. Router ID. So yes, in OSPF we have router ID concept. I'm using 22.22.22.22. So you can create areas. After that, you can advertise your network into areas. Bozuma, clear my point?
Yes, it's clear.
Let's
Yeah.
create some area. You can click on create new. So right now in our scenario, we are trying to create a regular area, like area 0, 10, 20, 30, 40. It's a regular area. Now
Mm-hmm.
we have other option. If you are familiar with OSPF spatial area concept, so yes, we have some spatial area in OSPF, NSSA area, right? And
Yeah.
stubby. These are not CCNA topic. These are CCNP topics.
CCNP. Yes, I forgot this. I
Yes.
used to
Okay.
study this,
So
but I
yes.
forgot.
Oh yeah. So no problem. But it's an area. My point is what NSSA and stub area
Mm-hmm.
option is available. You can create. But right now I'm creating a regular area. So now area 0, 0 dot 0 dot 0 dot 0. This is area 0. Just click on OK. In case if you want to create area 10, yes, 0 dot 0 dot 0 dot 10. Same format we have in Cisco router. Okay. Same format. If you check question mark, see, either you can type a number or you can type in this format. Okay, so this format is also available in Cisco router. Okay.
Mm-hmm.
Now I'm creating area 10. Okay, I'm creating area 20 just for example 0 dot 0 dot
Yeah.
0 dot 20. Click on OK. And now networks. Let's advertise our network. So I have network 200.200.200.0/24. And this network I want to advertise in area 0. Just click on OK. I have one more network 10.1.23.0/24. And this network I want to advertise in area 0. Just click on OK. Just click on OK and now click on apply. Click on apply. And you can verify on firewall. Get router info routing table all. So you can see now, yes, we are receiving some route information with O flag and O is what? OSPF routes. See,
Mm-hmm.
routes are coming from same area, right?
Yeah.
Routes are coming from same area. So these are what OSPF routes. I'm receiving route 1.1.1, 2.2.2. This is administrative distance. This is cost. So this is OSPF implementation. But in case if you want to use other OSPF feature option, you can. Okay, you can. Like see, can go to an interface. You can click on create new. In case if you want to change any interface cost, so you can change interface cost here. Authentication, yes, you can configure simple password authentication, or you can go with MD5 authentication. You can decide. Hello interval and dead interval you can change as per your requirement. And yes, in OSPF, it should be the same. Same hello interval, same dead interval. Otherwise, they cannot form neighbor relationship.
Mm-hmm.
Now click on advanced option, and now you can go with inject default route. Inject default route. Now, passive interface. Yes, passive interface is a common concept. You can use this concept in RIP protocol, in EIGRP protocol, in OSPF protocol. You can decide. Yes, in OSPF option is available. Okay, if any interface you want to use as a passive interface, you can. If you want to redistribute any protocol in OSPF, yes, just enable and click on apply. Clear now? This
Yeah.
OSPF
Yes.
implementation, simple task. Okay.
Yes. Clear. Yes.
Now let's go for BGP implementation. Okay. And if you don't know anything about BGP, don't worry about it. I'm only telling you the command syntax. BGP is not a CCNA topic. It's a CCNP topic. Okay, but try to clear the concept BGP configuration. So BGP, I'm trying to configure BGP in between. Border Gateway Protocol. It's a EGP protocol. You can say Exterior Gateway Protocol. So BGP, I'm trying to configure in between this R1 router and this FortiGate firewall. So both devices are in different AS number. In BGP, we have AS number, autonomous system number. For example, this router is a part of AS number 100, and this firewall is a part of AS number 200. It means I'm trying to configure eBGP. Okay, Ojuma? I'm
Yes.
trying to configure eBGP. So let's go to router, and let's delete this OSPF configuration. So commands and text router BGP. If you type question mark, asking for local AS number. Local AS number. So local AS number is 100. Local AS number is 100. Just press enter. And now you can define what neighbor command. Neighbor command, neighbor, then 200.200.200.1. This is firewall IP. Now remote AS is what? 200. Remote AS is what? 200. This router, this is firewall IP. This is what? Firewall IP. And this firewall is a part of AS number 200. So remote AS and remote AS number. Now press enter, and then we can advertise our networks. So network command 200.0 mask 255.255.255.0 network 1.1.1 mask 255.255.255.255/32. Let's go to FortiGate firewall, and we have same commands and text. If you compare with Cisco, we have same commands and text. Okay, see, you can go to BGP. First, you can define what? Local AS number. So this firewall is a part of local AS number 200. So local AS number is what? 200. Router ID 22.22.22.22. And yes, neighbor command. Yes, we have neighbor option. So we have same command syntax. Neighbor. And what is neighbor? Neighbor IP address is a router IP address 200.200.200.10. This is R1 fast Ethernet 0/0 interface IP. And this IP is a part of remote AS 100 as per our design. R1 is a part of remote AS 100. Just click on OK. Done. Now you can advertise your network. Yes, you can advertise your network. You can advertise here 200.200.200.0/24, and then 10.1.23.0/24. Just click on apply. Just click on apply. Settings saved successfully. And now you can check your routing table information. Get router info routing table all. Routing table all. And I'm not receiving route information. Why? Please wait. Okay, BGP is a slow protocol. Let's work with TCP. Wait. Let's go to R1. Yes, BGP neighbor relationship. Show IP BGP summary. Okay, this is neighbor IP address, BGP version 4, AS number 200. Now show IP route BGP. I'm not receiving route. Please wait. Yes, I'm receiving now. Ojuma.
Yeah,
It's
takes
working,
time.
but
Yeah.
it's working now. It's working, but it's working slow. So yes, we have some route with B flag, B code. This is BGP, and this is administrative distance. So in BGP, actually, we have two options. Either you can work with same autonomous system number, or you can connect different autonomous system number. If you are working with same autonomous system number, this is called IPGP. Okay, and here
Mhm.
into this scenario, we are working with EBGP.
EBGP. Yeah.
Okay, so IBGP administrative distance is 200 and EBGP administrative distance is what? 20. Okay, so this is what? EBGP.
Hmm.
So this is our topic, routing implementation in 48 firewall. I hope it's clear. Wajma.
Yeah, it's clear. Yeah, thanks.
Okay, let's talk about our next implementation. Next topic is called firewall policy. Let me start a new topology. Wait. Okay, this will take time. Let's take a break for 8 minutes. Wajma.
Okay,
Eight
yeah,
minute
it's good.
break.
8 minutes,
It's a
good.
12 17 on my side. After 8 minutes, we can continue at 12:25 my time. Okay.
Okay, yeah, it's good. Yeah.
Please turn off your mic
Hmm.
and let me reset this. Wait.
Okay, thanks.
Reset this firewall device. Hello, Pajama. Can you hear me, dear? Pajama, can you hear me? Can we start our discussion now?
Okay, I'm back here.
Okay. So let's prepare this topology, okay? I have one 48 firewall device,
Mm-hmm.
one 48 firewall device with LAN network and WAN network. Let me explain this topology. Wait.
Did you
Into this
send me
topology,
this topology?
I shared with you EVNG full pack, okay? Just
With
import
this
and you can
topology
get
as
all the
well?
topology. Yes.
Okay, yeah, good, thanks.
Yes. Now, see, this is topology. We have 48 firewall box, and this portion I'm using as a LAN side portion. And in LAN side portion, I'm using 200 series of IP. Okay, 200 series of IP. This is LAN side portion.
Mm-hmm.
And this portion, port number one, I'm using as a public side network in my topology. Public side network. Let's try to configure this. So 192.168, this is firewall IP. Port number one into this topology I'm using as a WAN port. So let's give an alias name for port number one. So simple topology, one firewall with LAN interface, WAN interface, and default route towards ISP. So alias is what? WAN for port number one and LAN port number two. As per topology, LAN port number two. So alias name is LAN, IP address 200.200.1/24, ping service, click on OK. And now you can click on static route. Okay, I'm trying to create default route. Okay, my point is one
Mm-hmm.
firewall with LAN interface, WAN interface, and default route towards ISP gateway. Clear?
Clear, yeah,
Simple
yeah.
topology. So for any unknown destination in my design, 1.1 is a next hop IP and exit interfaces WAN port number one. Basic configuration is complete. So
Mm-hmm.
if you go and check on your firewall device, get router info routing table on. So if you check your routing table, yes, for any unknown destination, you can go via ISP site, right? You
Yes.
can go via ISP site. So I have a default route towards ISP. In my topology, this cloud is what? This cloud is my ISP site network. So I have a default route towards ISP, so we can verify our internet connectivity, execute ping 8.8.8.8. I'm trying to ping Google DNS, and as you can see, I'm getting reply. Watch more.
Mm-hmm.
I have internet connection, okay, in 48 firewall. Now from inside machine, my point is from inside machine, if I'm trying to access, if I'm trying to initiate some traffic, okay, if I'm trying to initiate some traffic from inside LAN machine, wait. So from inside LAN machine, I'm trying to initiate some traffic. This traffic will go and hit on firewall device. Let's verify IP address configuration. So now let's verify IP address configuration first. My point is we have proper IP address configuration on LAN machine. What is proper IP address configuration? It means we have IP address, mask, gateway, DNS entry. You can verify now, right click, properties, local area connection, properties, and you can see now we have a proper IP address configuration, IP address, subnet mask, default gateway, and in my
Mm-hmm.
topology, this is DNS ID. So you can say we have proper IP address configuration on LAN machine. Okay. Let's initiate our
Yeah.
traffic. Let's initiate some traffic from LAN side network. This is IP address. Let's try to initiate our traffic. For example, I'm trying to ping 8.8.8. Okay, I'm trying to ping 8.8.8. So when you
Mm-hmm.
initiate this traffic, this traffic will go and hit on firewall device, right?
Yes.
Now, in this firewall, what you have a default route towards ISP. Default route towards ISP, but you can see traffic is not traveling. Traffic is not traveling through the firewall box. You can see this
Mhm.
inside machine is not getting reply. See, you cannot access. Request timeout. You cannot access. This firewall has a default route towards ISP, but he's not sending. This firewall is not sending this traffic through the firewall box. You can initiate more traffic. For example, I'm trying to access google.com, for example. Okay, I'm trying to access facebook.com, facebook.com. See, traffic is not traveling.
Mm-hmm.
Traffic is not traveling. I cannot ping 8.8. Why? Because this is firewall device. Clear now, this point? See, cannot access facebook.com, cannot access google.com. See, no internet connection. Bozuma.
Yeah, it's clear.
Okay,
Yeah.
so here we have a firewall device. Okay, this is firewall. That's why traffic is not traveling through the firewall box. Okay, and we are working with FortiGate firewall device. So if you want to allow your traffic from one interface, one interface to another interface, you need to configure policy. You need to configure policy. Let's go to FortiGate Firewall. FortiGate Firewall. And now you can go to check it. You can click on policy and object. Policy and object, you can click on firewall policy. If you click on firewall policy, you can see here we have a default rule. We have default rule, and this rule is called implicit deny rule. This is rule name. So here we have a default rule. And as per this default rule, if any incoming interface trying to go on any outgoing interface, any source IP, trying to communicate with any destination IP on any scheduled time to access any services, action is what?
Denial.
Deny. So if you are initiating this traffic, this 8.8.8 ping Google dot, if you are initiating this traffic, you are hitting this rule. You are hitting this rule. And because of this rule, action is what? Deny. Traffic is what? Deny. If you double click on this policy, you cannot edit this rule. Okay, this is implicit deny rule. See, any
Mm-hmm.
incoming interface, any outgoing interface, any source IP, any destination IP, action is what? Deny. Deny.
Yeah.
And in case if you are looking for log message, if someone will hit on this policy, if you are looking for log message, just enable this option and click on apply. So because of this policy, traffic is not traveling. Let's create some rule to allow our traffic. You can click on create new, and we are trying to create our first firewall policy. Okay, Bosma?
Yes.
First firewall policy. So now you can give a name for this policy rule. Okay, you can give any name here, LAN to WAN, trusted to untrusted, inside to outside. Okay, I'm
Mm-hmm.
using a name rule 1. So as per our task right now, as per our task, we are trying to allow our traffic from LAN to WAN
To
side,
WAN.
right?
Mm-hmm.
So as per our task, our incoming interface is what? Port number
Or
2.
two, yeah.
And our outgoing interface is what? Port number 1. As per our task right now, right? So let's
Mm-hmm.
go to policy. Incoming interface. So as per our task, incoming interface is what? LAN port number 2. And outgoing interface, WAN port number 1. Now you can add source information into this policy. Source.
Mm-hmm.
Okay, so this incoming interface port number 2. Source is what? You can click on plus sign. FortiGate is a object-oriented firewall. FortiGate, Palo Alto, Checkpoint, FTD, ASA. These are what? These are object-oriented firewall. Okay, so in these firewalls, you can create object, IP address object, services object, and these objects you can use in your configuration. Okay, so
Mm-hmm.
here what we can do, here we can create IP address object. We can create user object. How to work with user account, group account, we can discuss in a separate topic. Is called firewall authentication. Okay,
Mm-hmm.
but right now our focus is on policy configuration. So I'm trying to focus on address object only. Okay, I'm trying to add IP address information. So these are predefined address object. These are what? Predefined address object. If you click on add option, this is if you click on this all option, add, see, source is what?
Mm-hmm.
All. All means what? Any IP.
All, everything, yeah.
Any IP. So either you can use this any IP, any option, or you can create your object. You can create your object. Click on create new, click on address, and now you can give a name for this object. And these are the types. These are the type. We can create subnet object. We can create subnet object, IP range object, fully qualified domain name object, geographical location object. Dynamic is not your topic. MAC address object, yes, you can create. So let's create our subnet object first. You can give a name. For example, LAN hyphen network and subnet 200.0/24. Just click on OK. Just click on OK. And this object you can attach as a source. This object you can attach as a source. Source is what? LAN network. LAN network. So you can add your complete subnet, or in case if you want to create a policy for any specific IP address. So yes, you can give an object name, marketing hyphen PC1. It's just object name, Bosuma, okay?
Mm-hmm.
And
Yes,
here you
yeah.
can define, in subnet, you can define, your single IP address object. For example, 200.200.224/32. Single IP address object. Just click on OK. Just click on OK. And now this object you can attach. This object you can attach in your policy. Or you can create a range of IP object. You can go with range. Range. You can give a
Mm-hmm.
name. You can give a name. For example, marketing hyphen team 2. So range of IP 200, 200, 200. For example, 42, 200, 200, 200, 45. I want to create my policy for this 6 IP address. So 40 to 45, I can create range object, range object, and you can attach as a policy. You can attach in your policy. Now you
Mm-hmm.
can click on create new. You can click on address. You can go with fully qualified domain name object. For example, you have a big URL. You have a big URL and you want to give a small name. Small name. For example, I have server team.abc.com. and I'm giving a small name, FTP1. Just click on OK. This is what? Domain name object. Fully qualified domain name object. Serverteam.abc.com is not available in my LAN site network. I'm just giving you an idea. You can create fully qualified domain name object, or you can create geographical location object. For example, I want to block some IP address. I want to block IP address from some countries. So you can see here we have a big database in FortiGate firewall. FortiGate maintain this database. Maintain this database. So no need to search, okay? I'm a network administrator. I want to block some IP address from some country. Okay, I'm getting a continuous hit on firewall device. I want to block. So I need to check the list on Google. No need to do this, okay? FortiGate has a database. FortiGate has a database. For example, I want to block some IP address from Afghanistan. Just select this site. Type is for geographical location and you can give a name. Clear now my point?
Yes.
Now you can go with this topic is called what? MAC address object. Why MAC address object is required? Why MAC address object is required? Because IP address is what? You can change IP address, but you can't change MAC
The
address.
MAC, yeah.
Okay, for example, in your LAN site network, you are using DSCP feature. DSCP feature. So you are providing IP address on all machine through DSCP service. Every day they are getting different series of IP. Different series of IP. I want to configure policy for these 3 computers, but every day they are getting different IP address. So what I can do, I can go with MAC address object. I can create MAC address object because it's a fix. It's a fix. You can give a name, for example, sales-team, sales-user one. So you can either define your single MAC address or you can define your range of MAC address. For example, in your organization, you buy 100, 200 IP camera from same vendor. Okay. So all the devices have a range of MAC address. Also. Okay. So my point is you can create. Let's create, just for example, let's create MAC address object. So this machine, this inside LAN machine MAC address is, okay, so this is MAC address of this device, physical address you can say, or MAC address. So 5, we check 5000. So 550:00:00:04:00:00. So colon 04:00:00:00. Just click on, and this object you can use as a source. So right now, what I'm doing right now, I'm trying to use any right now. Okay. But yes, I will create multiple address object and we can use it in our policy. Don't worry about it. Okay. But right now I'm using what? Source any. I'm creating a simple policy first to allow my traffic. So source I'm using any. Okay, Bozuma?
Yeah, it's clear.
Now
Yeah.
destination, you can click on destination. So again, you can create your address object, or you can go with predefined internet services object. So FortiGate has a database about predefined popular internet services object. For example, if anyone trying to go on Facebook, Instagram, I don't know what series of IP address they are using, but you can directly attach this object. FortiGate has a database. So if you have proper license, then you can download some latest information. But right now we have 1531 internet services object. Let's go to address, and I'm using any destination right now. So any source and any destination. Schedule time always, or in case if you want to create your own schedule time, yes, you can click on create new. one-time schedule, and here you can go with one-time schedule or you can go with recurring option. One-time schedule and recurring option. So in one time, you can decide your start date, time, end date, time, pre-expiration, this event log, number of days before you can decide. Or in recurring, you can decide days, Monday, Tuesday. So these options are available in recurring. You can decide your start time and stop time. I'm not creating, okay? Let's go with this default option always. Always means what? Anytime, any day. Now services, once you define all the parameters, now you can add your services. Protocols you can say. So these are services, general services, web access services, file access services, email access services. See, we have lots of services here, protocols. For example, I'm trying to add TCP, UDP, HTTP, HTTPS. Just you can add, see, your services. Now, right now, what I'm doing, I'm trying to add any service. Right now, I'm trying to add any service. Once you define all the parameters, now you can take action. You can take action. You can go with accept or you can go with deny option. Accept means what? Traffic is allowed. If you are using action accept, it means traffic is traveling through the firewall box. And if traffic is traveling through the firewall box, then you can utilize these options. You can utilize these options. But if you select action what? Deny. So traffic is not traveling through the firewall box. And if traffic is not traveling through the firewall box, then you cannot utilize rest of the option. So we are here to allow our traffic, right? Ojuma?
Correct, yeah.
So action is what? Accept. If traffic is traveling through the firewall box, then this FortiGate firewall will inspect this traffic. And for inspection, FortiGate has two options: flow-based inspection method and proxy-based inspection method. Okay, if traffic is allowed, if traffic is traveling, FortiGate firewall will inspect this traffic. And for inspection, it has two options: flow-based and what? Proxy-based. What is the difference in between flow-based, and proxy-based inspection method? Okay, so I'm giving you 5 minutes, Bosma. Please read this information first. Okay, this is
Okay.
the comparison in between flow-based inspection method and what? Proxy-based. Okay, I'm giving you 5 minutes. Please read this information first. Okay, then we will continue.
Okay.
Wajuma, can you hear me?
Yes, I can, yeah.
What do you think? Which option is good?
Well, the one which is more secure,
Proxy based, right?
proxy-based,
So,
yeah,
so,
even
so
if
why
it's
why
slow,
we
yeah.
have flow-based inspection method? Actually, it's depend on scenario, right?
Correct,
Depend
yeah.
on requirement. Yes, for some application, for some traffic, I'm looking for faster response. Okay, then I can go with flow-based inspection method. Okay, but for some traffic, I'm looking for a better security, more feature. Then you can go with proxy-based. Clear now?
Clear, yeah.
Yes. So depend on scenario. Now, let's go to policy here. So now what I'm doing, I'm going with default option flow base. Now here is an option NAT. So NAT, I'm trying to enable NAT. What is NAT option? For NAT, we'll discuss here. We have a dedicated session for NAT discussion. Okay. So I'm not talking about what is this outgoing interface and dynamic IP pool. Okay. Wajuma.
Mm-hmm.
Right now,
Yeah,
our focus is on firewall policy. But NAT is enabled because traffic is traveling from private network to public network. So NAT is required. So NAT is enabled.
mm-hmm.
Now, security profile. Yes, we have a separate discussion, separate topic to discuss security profiles. Okay, so let's try to allow our traffic. Information, accept, and now log allow traffic. So yes, I'm looking for logs. If someone will
Mm-hmm.
hit on this firewall policy, I'm looking for logs. And in log allow traffic, you have two options, security events and all sessions. Security events and all sessions. Security events, if you select this option, it will show you all the logs related with this security profile. But if you want to verify all kind of logs, you can go with all session logs, this option. Just click on OK. Just click on OK. And here we have a policy. Here we have a policy and this policy in between LAN port number 2 to WAN port number 1. And this is policy name. This is policy ID.
Mm-hmm.
This is policy ID. It's not a request number. It's a policy ID. Okay. So
Yeah.
whenever you will create a new policy, 48 will assign a policy ID here. Now, any source trying to communicate with any destination on any scheduled time to access any services, action is what? Accept. So now let's try to initiate our traffic. Let's try to initiate. I'm trying to ping this time 8.8.8. And I'm getting reply. See, I can ping 8.8.8. I can ping google.com. Bojuma,
Mm-hmm.
see, traffic is traveling. You can refresh this page. You can refresh this page, facebook.com. It's working slow because it's a VM machine, but we can access. See, facebook.com, google.com. Let's refresh this page. Google.com, training.fortinet.com, cisco.com. See, we can access, right? Google.com. See, we can access, right? Google.com. We can access Facebook.com. Mozuma, clear for you? See,
Yes, it's clear. Yeah.
Facebook.com. Let's go to firewall device. You can right click onto this policy and you can go with show matching log. Show matching log. With show matching logs, you can verify the log information. Yes, you can see traffic is initiated from 200, 200, 127, right? This is source interface, incoming interface, outgoing interface, destination IP, action, policy ID. So this is policy ID, this is policy name. Clear now my point?
Yes, it's clear.
Let's go to policy again. Let's go to policy. And I'm trying to create a new rule. I'm trying to create a new rule. And this is what rule 2. Incoming interface LAN port number 2, outgoing interface WAN port number 1. Source. Source I'm using, not this time, I'm not using any. This time I'm creating object. Let's create an object. An object name is HR-team5. So I'm creating a range object here. Okay, 200, 200, 200, 100, 200, 200, 200, 150. So I'm creating 50 IP address object. Just click on OK. Just click on OK. Now this is what your object. Into this object, what we have 100 to 150. So 50 IP address. Destination. Destination is any. Services is what? Any. And action is what? Accept. No, action I'm using what? Deny. For this traffic. Action I'm using deny. Log violation traffic. So if 100 to 50, 100 to 150, if they are trying to access any destination, action is what? Deny. Mojuma, clear my point?
Yes.
If I'm trying to initiate my traffic this time, what do you think? If you check this machine IP address, so we are using 200, 200, 200, 127, right?
Mm-hmm.
And as per our configuration, if 100 to 150 IP address trying to access any destination, action is what? Deny.
Mm-hmm.
So what do you think? If I'm trying to initiate my traffic, what do you think? Can I access?
Yes,
Why?
because you have the first firewall rules covers all the IPs. You have to
Yes.
move rule 2 at the top.
Yes. Thank you so much. So here we have what? I'm talking about policy order. See, we are getting reply, right?
Mm-hmm.
We can ping google.com. We can ping 8.8.8. Traffic is traveling. Why traffic is traveling? Because you can see, let's talk about policy orders. Policy order. So whenever traffic will hit on firewall device, firewall will check this traffic information from top to bottom.
Mm-hmm.
From top to bottom. So okay, so this inside machine 127 is trying to initiate his traffic. This traffic will go and hit on firewall device. Firewall will check this traffic information into firewall policy from top to bottom. So this is your top rule, then next rule, then next rule, then next rule, next rule. So it will always check from top to bottom. So in top rule, source we have any. So this 127 is a part of any. So if any source trying to communicate with any destination, action is what? Accept. So it's going to hit this top rule. It's going to hit this top rule.
Mm-hmm.
And as per this top rule, traffic is allowed. Traffic is traveling. That's why this inside machine can access. See, I can ping. So firewall will not check this traffic information in next rule. No, because it's match here in top rule. In case if you want to utilize this rule, so just select this rule and drag on upside. Drag on upside. So now this rule is on top. If this rule is on top, so let's go to inside machine. And this time, if I'm trying to initiate my traffic, as per policy order, this traffic is blocked. Okay, when this inside machine initiate his traffic, this traffic will go and hit on firewall device. Firewall will check this traffic information from top to bottom. And this is top rule. Top rule. And into this top rule, 100 to 150 trying to access any destination. Action is what? Deny. So you can see now this inside machine cannot communicate. Clear now, Wajuma?
Clear, yeah.
Okay, let's change our IP address. Let's change our IP address. So I'm changing this machine IP address properties, Internet Protocol, TCP IP version 4, properties, and IP address I'm using 160. Just click on OK. Click on OK. Now you can check here. You can try to initiate your traffic this time. So if you are trying to initiate your traffic this time, this traffic will go and hit on firewall device. Firewall will check this traffic information from top to bottom. Okay, and into the stop rule, 100 to 150, trying to access any destination, action is denied. But now this machine IP address, is 160. 160. So it will not match here. If I'm trying to initiate my traffic, it will not match here. It will match on second rule. Next rule. And into this next rule, what we have? Source any. Source any trying to communicate any destination. Action is what? Accept. That's why traffic is traveling now. Clear now my point?
Yes.
Now let's create one more rule. Okay, why I'm creating this new rule? Because I want to show you whenever you will create LAN to DMZ, for example, whenever you will create a new rule, this rule will store bottom of the line. Bottom of the line. So let's create a new rule. LAN port number 2, outgoing interface WAN port number 3, source any, destination any, services any, and now action accept, just click on OK. So I want to show you whenever you are creating a new rule, it will store bottom of the line. But you can see it is not at bottom. It is on top. So this is not actual sequence, okay? This is not actual sequence. For actual sequence, you can click on by sequence option and you can see this rule is at bottom. This is interface pair view option. Interface pair view. For example, I want to verify all the policy in between port number 2 and port number 3. I want to verify policy in between port number 2 and port number 4. Then yes, we can go with interface pair view. You can verify all the policy. So if we have one policy in between LAN port number 2, port number 3, two firewall policy in between port number 2 and port number 1. Clear now?
Yeah.
Okay, so this is a graphical page. This is a graphical page. In case if you want to verify your policy information through CLI command, then CLI command. So let's verify command here. Username admin, password, show firewall policy command you can use to verify all policy information. And yes, this rule is on top. Okay, you can check now. You can click on by sequence. You can see now this rule is on top. Then next rule, and this LAN to the object. In case if you want to create any policy through CLI command, it's a very simple task. Just right click on any policy, click on edit in CLI, copy this configuration, and now we can paste in Notepad. Wait. Now, config firewall policy, command syntax is what? Config firewall policy. And now you can define your policy ID number. So you can see policy ID 0, 1, 2, 3. This is not a sequence number. This is just a policy ID number. So I'm
Mhm.
creating a new rule. For new rule, I'm giving policy ID number 4. Policy ID number 4. Now set name, set source interface, set destination interface, set action, set source address, set destination address, schedule services, NAT enable. So now I'm giving a name for this rule. I'm trying to create a rule. LAN to WAN hyphen rule 1. Set source interface, port number 2. Destination interface, for example, port number 5. Okay, source address, any destination address, any schedule time, any services, NAT is enabled, action is accept. You can copy this configuration and you can paste here. Done. Done. You can refresh this page. You can verify. You can refresh this page and you can verify your policy information. See, clear this point?
Yes.
Bojuma, I hope it's clear for you.
Right, it's clear, yeah.
This is firewall policy. Okay. Firewall policy. Now we are trying to focus on NAT concept. NAT concept. Next topic is what? NAT. So let's take a break for 10 minutes. Then we can start this new topic. Okay, Bojuma?
Okay, yeah, it's good.
On my
10
side,
minutes.
it's a 110. We will continue at 120. Okay.
Okay, yeah, it's good.
Please turn off your mic.
Okay, thank you.
Hello, dear. Can you hear me? Bojuma.
Yes, I can, yeah.
Okay, let's continue our topic now. Okay. We are trying to focus on NAT concept. Any idea about NAT? Can you please help me?
Mhm.
Any idea about NAT? What is NAT exactly?
Yes, NAT is network address translation, is the way how you translate from one IP to another,
One IP to another IP,
like
right?
from private to public. For example, when you go to the internet, you use NAT.
Yes.
We use
And we
NAT
have
as
three
well.
type of NAT, I think, right? Static, dynamic, and PAT.
Yes.
Let's revise our basic NAT concept again. Okay, wait. So I have a small topology. I have a netted device. Netted device, for example, router. This router is connected with LAN side switch. And in LAN side networks, we have multiple computers. This side, multiple computers. Now this portion is our ISP side portion. So in our private network, my point is this is our private network, and this is our public side network. So in our private network, I'm using private IP. Okay, 192.168.10.10, 10.11, 10.12, 10.13. So we are using private IP address. Now, in case if this 10.10 machine is trying to go on internet site, trying to access internet services, so it's required public IP. You need to translate. You need to
Mhm.
translate this private IP into public IP. And for translation, we have a concept is called NAT, network address translation. Now in NAT, we have translation configuration option. We have translation configuration option. We can go with static NAT. We can go with dynamic NAT concept. And the next option is what? PAT, port address translation. What is static NAT? What is a static NAT? Static NAT is called what? One-to-one mapping. One-to-one mapping. Manual configuration. For example, on LAN side network, I have 20 computers. If I'm using static NAT option, if I'm using static NAT option, then yes, I require 20 public IP. If you want to allow everyone to access internet traffic, I need 20 public IP for 20 private IP address. In a static NAT, you can create your translation entries statically, manually, so you can do your mapping. For example, this 10.10 IP, I'm trying to map with this 99.99.99.1. 10.11, I'm trying to map with dot 2. 10.12 with dot 3. Okay. So whenever this 10.10, 10.10 is trying to travel outside, okay, this will get this public IP and traffic is traveling. Traffic is traveling. Or if anyone from outside will hit on this public IP, static NAT is bidirectional. So if anyone from outside will hit on this public IP, as per your static NAT configuration, your router, your netted device will redirect this traffic on 192.168.10.10. Clear my point, Wajma?
Yes. Yeah.
In case if you are working in a small network, then yes, you can go with static NAT option. But in case if you are working with lots of computer, okay, if you have one or two server, then you can go with static routing. But in case, for example, you have 100 computers or 200 computers on LAN side network. So now, first I required 200 public IP. And if I'm going with a static NAT configuration option, I need to create 200 entry statically or manually into this NAT device. It's a very difficult task if I'm doing this in a big network. I need to create 200 entries statically, manually. That's why in a big network, I'm not using this option. In big network, I'm going with what? I'm going with dynamic NAT. In dynamic NAT, what you can do? Yes, for 200 private IP address, we require 200 public IP, 200 public IP, but this time I am not creating 200 entries statically manually. No. With dynamic NAT option, with the help of single command, you can create a range of public IP. You can create a range of public IP here. Now, if this time, if this 10.10 is trying to travel outside, it will get any IP address from this pool range and traffic is traveling. If 10.11 is trying to travel outside, it can get any IP address from this pool range and traffic is traveling. Clear my point, Wajma?
Yes, yes, clear.
Now, but again, we have an issue. Again, we have an issue in static and in dynamic NAT. We have an issue. Okay, for 200 private IP address, I need 200 public IP. This is the issue. That's why I'm not using static NAT, dynamic NAT. I'm going with PAT option. Okay, I'm going with what? PAT option. In PAT, what you can do? If I'm going with static and dynamic NAT, the problem is what? I need to buy 200 public IP. What about cost? That's why I'm using PAT option. What is PAT? In PAT, you can translate multiple private IP address with single public IP. Okay, this is your public facing interface. And here I'm using 99.99.99.100. So we can translate multiple private IP address with the single outgoing interface IP address. Okay, if this 10.10 is trying to travel outside, it can get any IP address and traffic is traveling. If 10.11 is trying to travel outside, it can get any IP. Sorry, it can get this outgoing interface IP and traffic is traveling. What is the packet format? My point is, what is the packet format? What is the packet format? If if 10 dot, my point is, if 10.12, this is 10.11, for example. If 10.10 and 10.11, if they are trying to communicate to same destination, for example, to same destination 8.8.8.8 and trying to access same service, port number 443. What is packet format? Wait. So into this topology, source IP, source IP, source port number, destination IP, destination port number. So what is source IP? Source IP is what? 192.168.10.10. And source port number, any random port number, right? 52,000, for example. Destination IP 8.8.8.8. Destination port number 443. Now in case if this 10.11 is also trying to access same destination. Wait. So if this 10.11 is trying to access same destination, source IP, source port number, destination IP, destination port number. So what is source IP? 192.168.10.11. Source port number 52,000. Destination IP is 8.8.8.8. Destination port number 443. Now this traffic will go and hit on router device. Router will create an entry for this traffic, and after that it will remove this source IP address information. Okay, from the packet, it will remove this source IP address information, and it will put this outgoing interface IP address as a source. So 99.99.99.100. It's a source IP. And now this traffic is traveling to outside. This is the actual traffic. Public IP is communicating with public IP. Now this 10.11, this traffic will go and hit on router device, netted device. First, this router will create an entry. After that, it will remove the source IP address information. It will put this outgoing interface IP as a source IP, 99.99.99.100. And traffic is traveling to outside. Clear my point, Ozma?
Yes.
What about return traffic? What about return traffic? If 8.8.8 will give the reply, my point is, when reply packet will hit on device, how your firewall or your netted device will identify, okay, the reply packet is for 10.10 or reply packet is for 10.11, because they both are translated with same IP. How your netted device will identify? Based on port number. Okay, so this is what, let me show you. This is not a port number. Okay, here we have a different port number because each machine assigned a different port number, right? 192.168.10.11. This machine is get 50,008, for example, 8.8.8, and port number 443. So now my point is, based on port number, your device can identify, because into this translation, you translate only this source IP. Clear my point?
Yeah.
Rest packet information is same. This is not a story, okay? I can show you practically. This information. So 99.99.99.100. So this traffic will go and hit on device. So based on port number, this router can identify, okay, 52,008. Yes, I have an entry in my device. So this reply packet is for 10.11. 52,000. Yes, this reply packet is for 10.10. Clear? I hope it's clear for you.
It's clear, yeah.
Okay. Now let's go to FortiGate Firewall. In FortiGate Firewall, we will discuss two type of NAT. In FortiGate Firewall, we will discuss two type of NAT. The first option is what? Source NAT. And second option is what? Destination NAT. And to configure source and destination NAT, we have two configuration option. The first one is what? Firewall policy NAT. And second option we can discuss is central NAT. So what is source NAT? What is source NAT? So this one is a great example. For source NAT. Source NAT. What you are doing into this topology? You are trying to translate your source IP, right? See, this IP will go and hit on router device. Router will create an entry, then it will put this outgoing interface IP address as a source, and traffic is traveling to outside. Mosuma, right?
Correct, yeah.
Into this scenario, we are trying to translate only source IP. So this is called source NAT implementation. So your static NAT, your dynamic NAT, your PAT option, these are what? These are called source NAT implementation. Source NAT implementation. Now, what about destination NAT? What about destination NAT? What is the scenario for destination NAT? So let's discuss a scenario for destination NAT implementation. Okay, wait. So I have a firewall device. Firewall device. This portion I'm using as a DMZ site network. Okay, this side we have multiple servers, for example. We have web server. Okay, we have DNS server. We have SMTP server. Okay, we have FTP server, for example. So now, and this portion is public site network, ISP site network. So this one is, for example, fast Ethernet 0/0. This is public facing interface. IP address I'm using 199.99.99.100. Into this topology, I can use PAT option. Into this topology, I can use PAT option. What is PAT? Remember our discussion? In
Mm-hmm.
PAT, we can translate multiple private IP. For example, here we have IP 192.168.10.10. This is 10.11. This is 10.12. This is 192.168.10.13. Now, so we can use PAT option here. We can use PAT. PAT is what? In PAT, we can translate multiple private IP address with this single public IP. Okay, if this 10.10 is trying to travel outside, it can get this public IP, traffic is traveling. In 10.11 is trying to travel outside, it can get this IP and traffic is traveling. Traffic is traveling. But now this time our task is different. This time our task is different. Wait, this is 10.30. This time our task is different. This time traffic is not initiated from inside network, from LAN side network. No, traffic is initiated from outside network. Clear my point, Osman?
Yeah, yes, clear. Yeah.
This time traffic is coming from outside network. It is initiated from outside network. So my point is, if this outside machine will hit on this public IP, this public IP. So how your firewall will identify? How your firewall will identify this traffic? This traffic is for web server, or it is for DNS, or it is for SMTP, or it is for FTP. How your firewall will identify? Clear this challenge?
Yes.
So we have a solution for this challenge. Okay, we have a solution. We can go with static NAT implementation. We can go with a static NAT, no problem. We can go with static NAT. We have 4 servers. Yes, I can buy 4 public IP, 99.99.150, 151, 152, 153. I can buy 4 public IP. 4 public IP. Now, static NAT. In static NAT, I can do manual entry. So this 150, I can map with this web server, 151 with this 10.11 DNS server, 152 10.12 SMTP, 153 with FTP. And static NAT is bidirectional. If 10.10 is trying to travel outside, it can get this public IP and traffic is traveling. Or if anyone from outside will hit onto this public IP address, as per your static NAT, this traffic will redirect on web server 10.10. So if I have one or two server, then yes, I can go with the static net. But in case if I have 10 servers, 15 servers, then 10 servers and 15 servers, then I cannot go with 15 public IP. Cosima,
Mm-hmm.
clear this challenge?
Yes.
So I'm not using static NAT option into the scenario. No, I am not using static NAT. No, what I'm doing, I'm using destination NAT concept. Okay, I'm using what? Destination NAT. In destination NAT, you need single public IP. In destination NAT, you need single public IP. For example, I have this public IP, 99.99.99.155. I need single public IP. If you remember PAT option, in PAT, we also require single public IP, right?
Mm-hmm.
In PAT, we can translate multiple private IP address with single public IP. In destination NAT, we have the same concept. So what is the difference? What is the difference? Difference in between PAT and destination NAT. So in PAT, you can translate. In PAT, you can translate multiple private IP address with single public IP. You can translate. But in DNAT, what we can do? In DNAT, we can map. We can map multiple servers with single public IP. We can map multiple servers with single public IP. Okay. This machine is what? Web server. This 10.10 is a web server. How? It's a web server because port number 443 is running, right?
Mm-hmm.
This is DNS. So port number 53 is open. SMTP port number 25. FTP port number 21, right? So in
Mm-hmm.
DNAT, we can map multiple servers with single public IP. How to configure DNAT? We'll discuss in our lab. Right now, I'm telling you the story, the concept. Clear my point?
Yeah, it's
So
clear.
this time, when this outside machine will hit on this public IP, will hit on this public IP, and if this request is for port number 443, if this request is for port number 443, so as per your DNAT configuration, your firewall will redirect this traffic on web server. Or if anyone from outside will hit on same public IP, because we have a single public IP. But if this request is for port number 53, then as per your DNAT configuration, your firewall will redirect this traffic on DNS server. If anyone from outside will hit on same public IP, and if this request is for port number 25 or port number 21, so as per your DNAT configuration, your firewall will redirect this traffic on SMTP and this traffic on FTP. Clear? This simple option.
Yes.
But again, we have a challenge here. Here we have a challenge. In case, if you have, for example, if you have multiple, if you have multiple servers, for example, this is web server 1 and you have web server 2, multiple web servers, then, okay, this is port number 25. My point is, if you have multiple web servers or if you have multiple FTP server in your network, FTP server 1, FTP server 2, IP address 192.168.10.14. Okay, this is what? FTP server 2. My point is this 150 and port number 21 is already mapped with this 10.13 port number 21, right? Bosma?
Yes.
It is already mapped, and this is standard port number. 21 is a standard port number for FTP service. Standard port number for FTP. So this public IP and this port number is already mapped. It is already mapped. What about this FTP2? Because outside user, what he can do? He can open his FTP application. He can put this public IP information in FTP application and port number. Standard port number for FTP is 21. This traffic will go and hit on firewall as per your DNet configuration. Okay, this public IP and this port number is mapped with this 10.13 port number 21. What about this FTP2? So here we can use a concept is called port forwarding. Okay, we can use a concept is called what? DNAT with port forwarding. Clear my point?
Mhm.
Port forwarding. In port forwarding, you can use any unregistered port number. You can use any unregistered port number. So, for example, I'm using 8999. 8999. This public IP and this port number, I can map with this 192.168.10.4 port number 21. But this 8999, this is not a standard port number for FTP, right? Bozuma?
Correct. Yeah.
So what we can do? So I can tell to my outside user as a firewall administrator, I will tell to my outside user, guys, whenever you will hit on to this public IP address for FTP service, please use port number 8999. Your outside users, they don't know anything. They don't know anything. This traffic will redirect on FTP1 or it will redirect on FTP2 or it will redirect on FTP2, FTP3. They don't know anything. Okay, what your outside user, what they can do, they can just open FTP application. In FTP application, they can put this public IP address information and port number 8999 they are using. This traffic will go and hit on firewall device, and as per your DNAT with port forwarding configuration, your firewall will redirect this traffic on 10.14. And this is not a story. I will show you practically. Clear now?
Yes, clear.
This is called what? DNAT with port forwarding. So let's try to implement this NAT concept. So we have two type of NAT to discuss. We have two type of NAT, source NAT and destination NAT. And to configure source and destination NAT, we have two configuration option. The first option is firewall policy NAT. And second option is what? Central NAT. Central NAT. So let's talk about first firewall policy NAT. And in firewall policy NAT, we can focus on source NAT and destination NAT. This is our topic first. So here we have a topology. Here we have a topology. Wait. Okay, so here we have a topology, one firewall device with LAN interface, WAN interface, and default routing towards ISP. Now I'm trying to create a policy to allow my traffic. So now I'm trying to create a policy to allow my traffic. So you can give a name for this policy, rule for incoming interface, outgoing interface, source IP, I'm using any, destination IP, any, services, I'm using any, and now you can see NAT option is available. NAT is enabled into this policy. So for translation, you can go with outgoing interface concept. For translation, you can go with outgoing interface concept. And as per our policy configuration, our outgoing interface is WAN port number 1. So it means we are trying to translate all source IP with this outgoing interface IP. And what IP address we are using? What IP address we are using? So we are using 192.168.1.190.
Mhm.
We are using this IP address. So let's go with this default option. Use outgoing interface address. Click on OK. Click on OK, and we can try to initiate our traffic. Google.com. Okay, let's try to initiate some traffic. Google.com, training.fortinet.com, facebook.com, ping 8.8. Traffic is traveling. Okay, traffic is traveling. It means translation is there. Okay, and yes, we have a policy, but our focus is on translation now. Traffic is traveling because of firewall policy and NAT policy, but our focus is on to verify translation. Translation is happened or not. So let's, okay, traffic is, it's working slow. Please wait. Google.com, I can access training.fortinet.com, facebook.com. So I can access. Let's go to firewall device. Let's go to firewall device and we can verify our translation information. So command is get system session list. Get system session list. And you can see now this 200, 200, 200, 160, 160 is trying to travel outside and it's getting this IP address. See, this 200, 260 is trying to access this IP address. This is destination port number, and this IP is translated with your outgoing interface IP. See,
Mhm.
clear now?
Yes.
This is 190 we are using on outgoing interface on port number 1. Let's go to policy now. Okay, let's go to policy. And in case I don't want to use this outgoing interface, I don't want to translate with my outgoing interface IP. Okay, so you can go to use dynamic IP pool. You can click on use dynamic IP pool. You can click on plus sign. You can click on create, and you can see multiple options are available. You can go with overload. You can go with overload, 1-to-1, fixed port range, and port block allocation. What is overload? Let's start our discussion with overload. So what is overload? If you remember our outgoing interface address translation method, so into this translation method, we are trying to translate all private IP address with this outgoing interface IP, right, Wasuma?
Correct. Yeah.
Okay, so IP address, we are using IP address here, 192.168.1.190. And with this IP address, we have a port number, 10242 65,535. So we have port range, right? This is
Mhm.
unregistered port number. Wherever inside machine will initiate its traffic, port number assigned. And we have limited port numbers. We have port range in between 10242 65,535. 35. So now, in case, see, here I have a single IP. In case if I'm working in a big network, okay, and my LAN users, they are initiating too much sessions. They are initiating too much traffic. Okay, so if this port number is exhaust, Okay, it's finished, for example. Then all your LAN users, they utilize this port number range because we have limited port number, right?
Mhm.
We have range from 1024 to 65,535. So what we can do into the scenario, I can buy 5 public IP. Okay, I can buy 5 public IP. But is it possible? Can I configure 5 public IP on a single physical port?
No.
No. So that's why we can use overload concept. I can buy 5 public IP, and these 5 public IP I can put in overload concept. Into this dynamic IP pool, I can go with overload. So for example, I have IP 192.168.1.140, 141, 142, 143, 143. So with each IP, we have a port range 1024 to 65,535. We have port range. We have port range. If this IP, if this IP and this port number is exhaust finish, then yes, we have next public IP, again port number range. Next public IP, again port number range. Clear my point?
Yeah.
So we can go with overload concept. Let's give a IP address 192.168.1.142, 192.168.1.145. So I have 6 public IP. Now we can give a name overload 11, just a name, object name. Click on OK. Now you can attach this object into the policy. I'm not using use outgoing interface address. You can click on OK. You can click on OK, and now we can try to initiate our traffic one more time. Wait. Google.com, Facebook.com, training.fortinet.com. Wait, it's taking time. I'm trying to ping 8.8.8, and traffic is, yes, traffic is traveling. I can access. Now let's verify our translation. So first you can clear your last session. So diagnose system session clear command you can use to clear your last sessions. And now we can check get system session list. So you can see now this machine is trying to travel outside, and it is getting IP address from your range. Remember your range 142,
Mhm.
145. Clear now?
Yeah.
Okay. Let's go to next option. You can go to rule. So overload. Next option is what? Next option is called one-to-one. In Fortinet, you can say one-to-one, but this is called what? This is dynamic NAT. This is what? Dynamic NAT. For example, in LAN side network, I have 10 private IP. 10 private IP. So I need to buy 10 public IP, and I can create a range here. range here. So yes, 10 private IP address. If anyone trying to travel outside, they can get IP address from pool range. So this is called what? One-to-one. So one-to-one and fixed port range, both are same. Both are same. But here is a difference. In one-to-one, you can only define your external public IP range. You can only define your external public IP range. Okay, but if you go with fixed port range, you can define your external public IP and your internal public IP. Okay, for example, only this specific private IP address can utilize this public IP range. Okay, so let's go with this one-to-one concept first. Okay, I'm giving a name, pool one, and public IP 192.168.1.151, 192.168.1.155. So I have 5 public IP. So from LAN side network, any five machine can utilize this public range. Just click on OK. Just click on OK, and this object we can attach in our policy. Just click on OK. Now you can try to initiate your traffic, facebook.com, training.fortinet.com again. Let's refresh this page. Now youtube.com, facebook.com again. Wait. google.com. So we can verify our session information. Wait, it's working slow. It's taking time, but we can access. Clear my point?
Yeah, it's
Okay, let's
clear.
verify our translation. So you can see now this 160 IP is getting your first IP from range 151. 151. Now let's go to policy again. Okay. And this time I'm trying to edit this object. And I'm using what? Fixed port range. I have a same public IP. In fixed port range, you can define your internal IP. Internal IP means what? 200, 200, 200, 151, 2. 200, 200, 200, 155. So only this private IP address can utilize this public IP range. Only this private range. Just click on OK. Let's verify. Let's verify port. Just click on OK. And this time, I'm trying to initiate my traffic. Okay, I'm trying to initiate my traffic. I'm trying to ping 8.8.8. I'm trying to ping 8.8.8. See, I'm not getting reply. See, Wajma,
Mm-hmm.
I'm not getting reply. See, if you check here, if you check google.com, if you check facebook.com, see, I cannot ping. I cannot ping 8 dot. Traffic is not traveling. Why? Because if you check IP address configuration, so this machine IP address is 160, right? And as per our translation configuration, if 151 to 155 is trying to travel, they can utilize this public range. So only 151 to 155. This machine IP address is what? 160. That's why I cannot ping 8.8.8. I cannot ping google.com. Traffic is not traveling. See, I cannot access Facebook.com. It's taking time. So let's change our IP address. Let's change our IP address. I cannot ping 8.8.8. I cannot ping google.com. Let's change our IP address, ncpa.cpl. See, I cannot access. Let's change our IP address. So now 200, I'm using here 152. 152. Just click on OK. Just click on close. Now you can verify your IP address configuration this time. IP config. So yes, 200.152. If I'm trying to initiate my traffic this time, okay, I'm trying to ping, for example, google.com. Okay, I'm trying to ping 8.8 google.com. See, I'm getting reply. Mozuma, clear? It's working. Because why?
Yeah.
Because as per our configuration 151 to 155, if they are trying to go on internet side, they can utilize this public IP range. Yes, inside machine can access. See, 8.8.8 google.com, traffic is traveling. Traffic is traveling. Clear now? Yes, this is what this is our fixed wait. This is our topic is called what? Fixed port range. Now let's talk about next option. It's called port block allocation. What is port block allocation? In port block allocation, we can limit the port numbers. We can limit the port number for each machine. For example, I have a single public IP 192.168.1.175, single public IP. With this public IP, we have a port range 102.4.2.65.535. Right? This is our range. This is our range. Now, this is range hour. Okay. Now in our LAN side network, I have multiple computers and they are initiating too much traffic. They are initiating too much traffic. For example, these three computers, they are initiating too much sessions. Too much session, too much traffic. So it means they are utilizing too much port numbers. If I want to limit the port number for each machine, for example, each machine can use only 500 port numbers. 500 port numbers for each machine. Clear my point? This is called port block allocation concept. It's a great feature in Fortinet. Okay, now you can give a name. Let's give a name for this. Port block 11. Now I have a single public IP 192.168.1.175. This is default block size. Default block. Okay, wait. 192.168.1.175. So this is default block size 128. Block per user 8. I'm not changing anything. Just click on OK. If you click on OK, it will do some calculation in background. I'm not talking about calculation, but it will do some calculation in background and it will give you the output. Output is what? Block per IP is 472. So each machine can utilize 472 port numbers. If you change something, for example, 105, it will do some calculation in background. And now we can get the output. Output is what? Now for each IP address, Block is what? 604. Clear my point, Wazuma?
Yes, it's clear.
I cannot initiate too much traffic, but for verification, I can show you translation is happened or not. Okay, translation is happened or not. So I'm trying to ping 8.8.8. I'm trying to access facebook.com. Okay, I'm trying to access training.fortinet.com. So you can verify now. Wait. Now let's try to verify our translation information. Get system session list. So you can see this machine, this 152 is translated with this IP 175. Clear now, Bozma?
Yes, it's clear.
This is what? This is our source NAT implementation. Firewall policy, source NAT implementation. And now we can talk about firewall policy, destination NAT. Firewall policy, destination NAT. Okay, so let's take a break for 10 minutes. Okay, Cosmo.
Okay.
Then we can start our destination NAT implementation. So it's a
Okay.
212 on my side. We will continue at 222. Okay, after 10
Okay, it's
minutes.
good.
Please turn off your mic.
Okay, thanks.
Hello, dear. Can you hear me? Bojma? Hello, dear. Can you hear me? Bojma?
Yes, I can hear.
Okay. Let's continue our topic now.
Mm-hmm.
So we are trying to focus on destination NAT implementation in firewall policy, destination NAT implementation. So if you remember our discussion on destination NAT, in destination NAT, we can map multiple servers with single public IP, right? For example, this side we have some servers, web server, SMTP server, DNS server, FTP server, and I have single public IP 192.168.1.115. So I can map multiple servers with single public IP. If anyone from outside will hit on this public IP address, and if this request is for port number 443, so as per your DNet configuration, your firewall will redirect this traffic on web server. Or if anyone from outside will hit on same public IP, if this request is for port number 25, so as per your configuration, mapping your firewall will redirect this traffic on SMTP server. Clear our discussion?
Yes,
And if you have multiple SMTP server, multiple web server, or multiple FTP servers, then you can use port forwarding concept. Port forwarding concept. DNAT with port forwarding. So in our topology, in our design, we don't have any web server, SMTP, DNS, FTP. Then how we can do our testing? How we can do our testing? So we can use this machine as a telnet server. Okay, this machine I'm using as a telnet server. This machine IP address is, let's verify this machine IP address. IP config 200.200.200.152. So 200.200.200.152. This is telnet server IP address. Now outside I have a public IP 192.168.1 dot, for example, 115. So this public IP I can map with this 200.200.152. I'm trying to map port number 23 with port number 23. So anyone from outside, for example, this outside machine, what he can do, he can open his telnet application. In telnet application, he can put this public IP information and port number 8 port number 23. So this traffic, your firewall, this traffic will redirect on this machine on port number 23. Clear my point, Bosuma?
yes, it's clear.
Now, in case if this one is your telnet server 2, okay, your second telnet server. Okay, so you can use port forwarding concept also. So I can show you port forwarding. Okay, for example, I'm using 8999 for port for this public IP, this port number I can map with this 200.200.152 port number 23. Okay, now let's go to configure this. So let's verify this machine is working as a telnet server or not. Okay, I think telnet service is enabled because I'm using same topology for other batches. So let's verify. You can first check services.msc. services.msc. So you can search for telnet. Yes, telnet is available here. If telnet is not available here, so you can go to control panel. You can go to control panel. You can go to programs. You can click on turn window feature on off. Turn window feature on off. And now you can enable this telnet server and telnet client feature. Okay. So it is enabled already in my scenario. Once you enable this, then what is the next step? Next step is you can open services.msc. You can search for telnet service here. Telnet service, right click on telnet, go to properties, start to type automatic, and you can click on apply and then click on start. Okay, now what is the next step? You can go to my computer and you can set a password, my computer, manage, and password I'm using 12345. So you can check now local users, and right click on user one, set password. Password I'm using 12345. Let's configure again 12345, 12345. Just click on OK, click on OK. And now let's go to FortiGate Firewall device. Username admin, password 123. So for DNet configuration in FortiGate Firewall, you can create virtual IP object. Wazuma, can you hear me?
Yes, I can.
For
Yeah.
DNet configuration, you can create virtual IP object. You can create virtual IP object. And this object you can use in your policy configuration. So let's go to create new virtual IP. You can give a name for this virtual IP. For example, I'm giving a name DNet-IP1 object name. So you can define your external public IP and map to IP. So external public IP, as per our design, our external public IP is 192, 192, 168, 1.115. Now map IP, so inside machine IP is for 200, 200, 200, 152. And now you can click on for port forwarding. You can enable port forwarding here. Just enable this option, port forwarding. And you can define your external service port and map to port. So external service port is, I'm using 8999, and this 8999 port number, I'm trying to map with port number 23. I'm trying to map with port number 23. So if anyone from outside will hit on this public IP with this port number, external service port number, this will redirect, this will map with 200, 200, 152 with port number 23. So this object you can create, and this object we can use in our policy configuration. We can use in our policy configuration. Let's create a rule. And this time, traffic is coming from outside, right, Cosmo?
Yes.
And going to LAN side network. So our incoming interface is port number 1 and outgoing interface is what? Port number 2.
True.
So let's go to here, policy. You can give a name, for example, WAN to LAN. Incoming interface WAN port number 1. Now outgoing interface LAN port number 2. Source IP, anyone from outside? Anyone from outside? What about destination? So in destination, you can add your virtual IP object in destination. Your DNet object you can attach. What we have into this DNet object, if you click on here, what we have, if anyone from outside will hit on this public IP with this external service port number 8999, it's mapped with this 200, 200, 152, port number 23. Done. Services, all services. And now you can go to all session logs, click on OK. Click on OK. Now from outside, I can try to initiate my traffic. Let's go to outside machine. So outside machine, outside users, they don't know anything about this inside LAN. No. Outside users, they can only hit on public IP. They can only hit on what? Public IP. They can only hit on this public IP. Okay, so this traffic you can go to. First, you can verify IP address configuration. So I'm using DSCP option for IP address configuration. So this internet cloud will provide IP address information. Let's check here. So I'm using DSCP option. So this internet cloud automatically provide me same series of IPs. I'm using DSCP option. Click on OK. Wait, let's verify IP address configuration. So I'm using same series of IP 192.168.1.13. So from outside, I can ping to this public IP 192.168.1.19. This is public phase interface, right, Mosma? Port number
Correct.
1, right? So if I have reachability, so you can open your telnet application. I'm using Putty application, telnet service, public IP. So outside users, they can only hit on this public IP 192.168.1.115. Let's try with the default port number. Click on open. As per our configuration, 8999 port number is mapped with port number 23 as per our configuration. So you can see this inside machine cannot access. See, cannot access. Let's try. Let's try for telnet service again. So from outside, I'm trying to hit on 192.168.1.115 and port number 8999. You can just click on open. Open. If everything is okay, you can get a login page. See, Microsoft Telnet Service. Mozuma.
Yeah.
Now username inside machine. Inside machine username is user1 and password 12345. This is inside machine telnet service. How you can believe this? So let's go to desktop and I'm creating a folder mkdir dnat11. So you can refresh this page. See?
It's added.
Okay, you can create mkdir. Wait. mkdir Fortinet Firewall. See? Clear now?
It's clear, yeah.
This is our DNAT implementation, destination NAT. Okay, so we complete our firewall policy NAT, source NAT, and destination NAT. So we can configure source and destination NAT with firewall policy NAT. What is the use of central NAT concept? Central NAT. So, okay, before discuss about central NAT, let's try to enable central NAT first. So central NAT is not enabled by default. It is not enabled by default. If it is enabled in your firewall, so you can get a tab here is called central SNAT. This tab is not available, so central NAT is not enabled. How to enable? You can go to system, you can click on settings, You can click on settings and you can go to this option, central SNet. Just enable this. Enable and click on apply. In case if you want to enable through CLI command, so config system settings, set central NAT. Question mark, you have two options, enable and disable. So enable, I want to enable. When you press enter, you are getting a message, right?
Mhm.
You are getting a message. Cannot enable central NAT with firewall policy using IP pool. So remember always, either you can use firewall policy NAT or you can use central NAT concept. You cannot use both options at the same time. Okay. So we
Mhm.
are facing this problem. Why? Because we have some
Yeah, use
policy.
it.
We have some firewall policy NAT, right?
Mhm.
Let's delete this rule. I don't have any policy. I don't have any, wait, I don't have any policy. I don't have any rule. Let's try to enable this time. Set central NAT enable. This time I'm not facing issue. See, you can type end command to save your configuration. Now you can refresh this page. You can refresh this page and you can see a new option, central SNAT, right?
Mhm.
Central SNAT. This is what? Central source NAT. And this is what? Central destination NAT. If central NAT is not enabled, this tab is called only virtual IP. If central NAT is enabled, so this tab is called what? This tab is DNAT and virtual IP. Clear this point?
It's clear, yeah.
Okay. So now the point is why we need central NAT. Let's talk about scenario. Okay, central NAT. So if you remember your firewall policy NAT implementation, wait. Policy NAT implementation, firewall policy NAT implementation. For example, I want to create policy in between port number 2 and port number 3. Yes, I can create a rule. Okay, I can create a rule. I can define incoming interface, outgoing interface, source IP, for example, 200.200.200.55/32. Single IP object. Destination IP is any service or protocol you can add. Action is allowed. Now we can attach our translation option. So for translation, I'm using outgoing interface concept. Outgoing interface. Let's create a new rule. Next rule. Next rule in between port number 2 and port number 3. So port number 2, incoming interface, outgoing interface, source IP 200.200.200.6265. I have a range of public IP. I have range of IP into this policy. Destination IP, wait. Destination IP, I'm using any into this policy. Traffic is allowed, so we can use translation option, outgoing interface. So my point is, if I'm creating firewall policy in between port number 2 and port number 3, for example, I'm creating 100 firewall policy or 200 firewall policy in between port number 2 and port number 3, every time I need to attach translation option. Yes or no?
Mhm. Correct.
Right? Every time. So in case if I have any centralized management option, then centralized management option. And this is not a new feature. Okay, this is not a Fortinet firewall feature something. No. If you go in Palo Alto firewall device, we have separate tab. We have separate tab for policy configuration, separate tab for NAT configuration. If you go with Checkpoint, so we have separate tab for policy, separate tab for NAT. If you go in FTD, Cisco Firepower Threat Defense, next generation firewall. So we have separate tab for NAT implementation and policy implementation. In Fortinet, this concept is called central NAT. Okay, we have two separate tab for firewall policy and separate tab for NAT. So this is not a new concept, a great feature. Okay, it's a common feature. In Fortinet, you can say central NAT concept. Clear now my point?
Yes.
So we can create our translation rule on a centralized location. I'm not going to add translation entry every time in policy. No. So here is the option. Wait. So here is the option. You can go to central NAT. Central NAT. You can click on create new. So these informations you can add in policy. Incoming interface, outgoing interface, source IP, and destination IP. So incoming interface. Okay, let's paste here. Wait. So now I'm trying to create a NAT rule on a central location. So incoming interface, I'm using port number 2 is the incoming interface, and outgoing interface is port number 3, and source address I'm using any, destination address I'm using any, and for translation I'm using outgoing interface concept. So my point is this single NAT policy rule can handle multiple firewall policy in between port number 2 and port number 3. See, this 200, 255 is a part of any. This 200, 260 to 65, it's a part of any. So this single translation rule can handle multiple firewall policy. Clear my point?
It's clear. Yeah, it's clear.
So this is a concept, central NAT. Okay, central NAT concept. Let's go to firewall box. And I'm trying to create a rule. Incoming interface, LAN port number 2, outgoing interface, WAN port number 1. Source IP, I'm using any. Destination IP, I'm using any. And for translation outgoing interface address, just click on OK. So now if I'm trying to create my policy, to allow my traffic, yes, you can define all the parameters. In policy, you can define all the parameters. Action is what? Accept. But you can see NAT option is not available. We are getting a message here. Central NAT is enabled. So NAT setting from matching central NAT policy will be applied. So now for translation, firewall will check central NAT. Let's create a rule. Rule 1, incoming interface, outgoing interface, source IP, destination IP, services. Now action accept. Just click on OK. And now you can wait. You can try to initiate your traffic. You can verify traffic is traveling. It's working, right?
Yeah.
So this is what our central source net. For central destination net, yes, you can go with center. This is our DNet object. Remember our DNet object in firewall policy net configuration,
Mm-hmm.
this DNet object. So let's verify our destination net, in central net. Let's go to policy. You can click on create new, and I'm creating a rule. WAN to LAN, incoming interface, outgoing interface, source IP, any destination IP. So what we can do in destination IP, in destination NAT, remember our firewall policy NAT discussion, we can
Mm-hmm.
attach our DNet object, right?
Correct. Yeah.
But here we don't have any DNet object. See, it's not visible here. Why? Because for translation, we have centralized option, right? Central
Mm-hmm.
NAT is enabled now. So I'm using destination any. Otherwise, you can create your object. Services, I'm using any. Just click on OK. So if traffic is coming from outside going to LAN side network, then firewall will check. Okay, let me check NAT rule. Is there any NAT rule option? And in DNAT, traffic is always initiated from WAN side network. So firewall will check. Let me check this NAT rule. And yes, I have a translation. So this is what destination NAT. We have a destination NAT rule on a centralized location, this DNAT object,
Mm-hmm.
and this is central source NAT. Clear my point, Pozuma?
Yeah, it's clear. Yeah.
This is our topic. This is our topic is called what? Wait. NAT. NAT. So we complete this topic, this section. And now we can talk about, we can discuss security profile, but not today. On Monday, we can discuss. Today, we'll focus on layer 2 firewall. Okay, let's discuss this a small topic first. Okay,
Mm-hmm.
let's discuss this small topic. It's called layer 2 firewall implementation. Wait. Okay, let's take a break for 10 minutes, then we can continue. Okay, dear?
Okay, it's good.
We will continue at 3 p.m. my
Mm-hmm.
side. Please turn off.
Good. Okay.
Hello dear, can you hear me? Wazuma?
Okay, I'm
Okay,
back.
have you set up the lab, or in case if you need help right now, so I can help you?
I did it, but on another computer, another laptop.
Okay.
But everything
Can I
is
share
fine.
one lab setup video so that it can help you to set up the lab?
Yeah, sure, yeah.
Okay. I will share today, okay, after this session.
Okay, thanks.
Okay. Okay, so let's talk about next concept is called firewall mode. Firewall mode, okay.
Mm-hmm.
We can use our firewall device. We can use our firewall device in two mode. Either we can use our firewall device as a layer 2 firewall, or you can say transparent firewall device. Transparent firewall device. Or you can use your firewall box as a layer 3 firewall box, or you can say NAT mode firewall. NAT mode firewall. So in case if I have a firewall box, and this firewall box I'm using as a layer 3, for example, as a layer 3.
Mm-hmm.
So these interfaces are called L3 interfaces. It means we can configure IP address on these interfaces. It's L3 interfaces. We can configure routing in firewall box. NAT we can configure, VPN we can configure, and it's a next generation firewall device. So we can utilize next generation firewall feature. And now you are familiar with layer 3 firewall implementation, right?
Mm-hmm.
Remember our routing configuration, NAT configuration.
Yes.
So you are familiar with layer 3 firewall. Now, in case if I'm using this complete box as a layer 2 firewall, in case, so these interfaces are called L2 interfaces. These interfaces are what? L2 interfaces. Okay, it's not a switch port. No, it's a layer 2 interface. It means we cannot configure IP address on these interfaces. We cannot configure IP address. We cannot configure routing onto this box. No, NAT, no, VPN, no. But it's a next generation firewall device. So you can utilize next generation firewall feature. So the point is, here we have limitation, right?
Mm-hmm.
With layer 2 firewall, we have limitation. With layer 2 firewall, we cannot configure routing, NAT, VPN, no. But in case if I'm using this complete box as a layer 3 firewall box, yes, I have a great feature. If my box is what? L3 firewall box, I can connect with internet directly. I can configure IP address on interfaces. I can configure routing, NAT, VPN, yes. So with layer 2 firewall, we have limitation. So in this scenario, we can use our firewall device as a layer 2 firewall box. Because with layer 3 firewall box, we have great feature. What is the scenario for layer 2 firewall implementation? So let's discuss a scenario. Okay, wait. Okay, so I'm working in an existing routing switching topology. For example, this is a router. This router is public facing router, and this portion I'm using as a LAN side portion. LAN side, we have multiple computers. Multiple computers. Now, into this topology, wait. Into this topology, everything is working fine. Everything is working fine. Okay, this inside machine can send his traffic to the switch. Switch is forwarding traffic to the router, and based on routing table, the router is forwarding traffic to the outside. Clear my point?
Mm-hmm. Clear, yeah.
Okay. Router is forwarding traffic to the outside. Everything is working fine into this topology. Now I want to deploy a firewall box here. I want to deploy a firewall box into this existing scenario. Okay, this is your LAN subnet, and this is your WAN subnet. So I want to deploy a firewall box into this existing scenario. Okay. For example, if I'm using this firewall box as a layer 3 firewall box. if I'm using this firewall box mode as a layer 3 firewall box, so these interfaces are called L3 interfaces. It's L3 firewall box, so each interface will participate in different subnet. Each interface will participate in different subnet. My point is, this single subnet is now divided into different subnet. This portion, different network. This portion, different network, right? Osmo?
Correct, yeah.
You need to change your existing IP address scheme into this topology. If you are trying to deploy your firewall box as a layer 3 firewall box. So no problem, you can deploy your firewall box as a layer 3 firewall box in case if you want. You can change your existing IP address scheme and you can deploy, no problem. But in case into this existing topology, I don't want to change any IP address scheme. No. Into this live network, I don't want to change IP address scheme. I don't want to change anything into this live network, but I want to deploy a complete next generation firewall device. So I can go with layer 2 firewall implementation. Okay, I can go with layer 2 firewall implementation. So this portion is what? Again, it's a LAN subnet. It's a layer 2 interface, so we cannot configure IP address. But yes, we can give a name. It's a LAN interface. It's a WAN interface. For example, port number 2, port number 3. To allow your traffic from one interface to another interface, you can configure policy. Clear my point, Bozuma?
Yes, it's clear.
So where we can deploy our firewall box as a layer 2 firewall box, okay, in existing network, in a live network where I don't want to change anything and I want to deploy a complete next generation firewall device. So I can deploy this firewall box as a layer 2 firewall box. It's a next generation firewall, so we can utilize next generation firewall feature. But we have limitation, okay? If this box is a layer 2 firewall box, we cannot configure routing, NAT, VPN. No. Clear this scenario?
Yeah, it's clear, yeah.
So my point is, I have layer 2 firewall. As I said, you cannot configure IP address on these interfaces. No, you cannot configure IP address on these interfaces because it's a layer 2 firewall. This is port number 1, port number 2, port number 3. So you can connect, for example, here I have management PC. I want to access this layer 2 firewall device with HTTPS connection, graphical page, or through CLI option, SSH. If I want to access, I need IP address, and we cannot configure IP address on any interface. Not possible because it's a layer 2 firewall. It's a layer 2 firewall. So if I'm connecting my cable, my point is, if I'm connecting this cable, port number 1, with this management PC, I cannot configure IP address. So if I want to manage this complete layer 2 firewall box from this management PC, what I can do? Ozima. Okay, let's talk about switching scenario. If I have a layer 2 switch, okay? If I have a layer 2 switch and I want to access this layer 2 switch from this PC, I can connect this PC with layer 2 switch port. For example, this is 0/22 and this is layer 2 switch. I want to access this layer 2 switch from this PC through telnet service. Telnet service. It's a layer 2 switch, so I cannot configure IP address on any interfaces. So how can I access this layer 2 switch? Remember, we have VLAN concept, right? We
Yes, with
have
the VLAN.
VLAN concept. We have VLAN 1. We can
Yeah,
configure IP address on VLAN 1, right? And this IP, through this IP, we can access this layer 2 switch, right, Bozuma?
Yes, the
Same,
gateway. Yeah.
same kind of concept we have in FortiGate firewall. Same type of concept we have in FortiGate firewall. In FortiGate firewall, what we have? We have management IP concept. Management IP concept. You can configure management IP. And this is a layer 2 switch IP address. Okay, let me show you practically. Wait. So I have a small topology for layer 2 firewall implementation. This R2 is public facing router into this design. This R2 is what? It's a public facing router. Okay.
Mhm.
And this portion and this portion is called LAN side portion. This portion is what? LAN side portion. LAN 200, 200.0/24. Now let's try to configure IP address. So this is LAN portion. That's why I'm using same subnet on. This portion is what? Your LAN size subnet. Wait. This R1 I'm using as a LAN machine. So 200, 200.200.200.10 mask, no shutdown. This R2 is public facing router. So 0/0 IP address 200.200.200.15 I'm using. This is gateway IP for all LAN machine. And now we can go to FortiGate firewall. So this firewall default mode is layer 3. Osuma, can you hear me?
Yes, I
This
can.
firewall default mode is what? Layer 3. Let's verify first. Wait. Okay, let's try to log in. So password 123, config system interface, edit port number 1. So we can configure IP address on interface. So this firewall default mode is L3 firewall box. Let's try to access 192.168.255.190 IP. So this firewall is a layer 3 firewall. Okay, you can verify on dashboard. On dashboard, you can verify in system information. You can verify your firewall mode. Now, if you click on network tab, then yes, you can configure routing options, static routing, advanced routing. You can configure. You can go to interface tab. If you select any interface, for example, port number 2, So yes, you can configure IP address on interfaces. You can go to policy. Let's create policy to allow our traffic. You can click on create new. In policy, you can define all the parameters. Action is what? Accept. Action is what? Accept. Then now what we have? Translation option. NAT you can configure. Now you can click on VPN tab. And this is what? VPN option. VPN option. You can implement VPN here. IPsec VPN, IPsec VPN, and SSL VPN. Clear now, Mozuma?
Yes, it's clear.
So I want to use this firewall box as a layer 2 firewall box. It's simple task. You can go to firewall box, CLI command, config system setting is a command. Now set OP mode, operational mode. Question mark, you can see you have two options, NAT and transparent. So I'm using this firewall box as a transparent firewall device. You can press enter. Now you can set management IP, set management IP. So 192.168.255.175 I'm using. So now this complete layer 2 firewall IP address is 175. You can access with any port. This is complete firewall IP address. So 175. You can set gateway IP. Why gateway IP is required? Because this is layer 2 firewall. We cannot connect this layer 2 firewall with internet because we cannot configure routing. But this is next generation firewall device. So to utilize next generation firewall feature, yes, you need to download latest signature update, application signature, antivirus signatures. You need to download signatures. And to download signatures, yes, this firewall is also required internet connection. So here you can set a gateway IP into this firewall. If this firewall is trying to go on internet, this firewall has what? Gateway information. So you can set a gateway IP. Like in my computer, if I'm trying to go on internet site, yes, I have default gateway IP, right? Yes. So let's go to here. Let's go. Now set gateway 192.168.255.1. Now you can type end command. Done. See, changing to TP mode. Changing to TP mode. You can refresh this page. You cannot access. Why? Because this firewall IP is changed now. Okay, now you can access this firewall device with 192.168.255.175. Okay, this firewall is not a layer 3. This firewall is what? It's a layer 2
Layer two.
firewall. You can verify in system information. In system information, you can verify firewall modes. And if you go to check network tab, you can see static routing, advanced routing. No, option is not available. Clear now?
Yeah.
You can click on interface. You can select your interface, any interface, for example, port number 2. You cannot configure IP address. See, IP address configuration option is not available. So now what I'm doing, I'm giving a name. It's a LAN interface service you can enable. Port number 3, I'm using as a WAN. Alias, just a description. Service, click on OK. If I'm trying to create my policy to allow my traffic, yes, I can create IPv4 policy. IPv4 policy, you can click on create new. You can define all the parameters. Okay, action is accept, but you can see NAT option is not available. Right? If you check VPN tab, see, VPN tab is not available. See?
Yeah.
Rest options are same, Masuma. Okay. There's security profile, user devices, login report, policy. These are the common tab. Okay. Common tab
Yeah.
in layer 3 firewall and layer 2 firewall. Clear? This is a small topic.
Yes, clear. Yeah.
Okay. Let's create a rule to allow our traffic. Okay. Before create our rule, let's try to initiate our traffic. Ping 200.200.200.15. Okay, I'm trying to verify my connectivity from this machine to this machine, same series of IP. 200.200.15. I'm trying to verify my connectivity and I don't have reachability. Success rate is 0%. Why? Because we have firewall box, and to allow our traffic, we can create rule: incoming interface, outgoing interface, source IP any, destination IP any, services any, and now action accept. All station logs, click on OK. So we have firewall policy to allow our traffic. So you can now try to initiate your traffic. Yes, traffic is traveling through the firewall box. Clear this lab?
Yes, it's clear. Yeah.
Okay, this is our topic. So this is our topic is called what? Layer 2 firewall. Now we will continue our topic on Monday. Okay. And this is our topic. We'll start our security profile discussion. Okay, Bozma?
Okay, that's good.
Monday, same time. Okay, dear?
Okay, it's good.
Bye, take
Thank
care.
you.
I'm
Okay,
sharing
thank
this
you.
recording after 1 hour. Okay?
Okay, that's good. Yeah.
Bye,
Thank you.
bye, bye.
Thanks.
Take care, dear. Bye.
Yeah, you too. Bye bye.